All right, solution seekers, welcome back. You have been busy identifying problems and coming up with some seriously awesome ideas. But today is where the real fun begins. So you've probably got a notebook just packed with all these great potential solutions, which is amazing. But now what, right? That's the big question. How do you take all of that incredible creative energy and actually, make something real out of it? Well, that's exactly where we are today. We're jumping right into step 3 of the engineering design process, the plan. And trust me, this is the good part. This is where your idea stops being just an idea and starts becoming real.
So, first things first, we're going to break down how you actually go from this creative spark to a solid, concrete action.
And, the very first part of taking action, it's making a choice. And sometimes it's a tough one. You've got all these amazing solutions, but you have to pick just one. This is so critical because picking the right idea from the get-go saves you a ton of time and resources later. So, how do the pros do it? I mean, it can be really tricky, can't it? When you've got a bunch of good options, it's tempting to just pick the one you think is the coolest. But it's not about your favorite. Nope. It's about picking the smartest one, the one that actually has the best shot at working. Engineers have a secret weapon here. They don't guess. They use a checklist. They basically put every idea to the test with 4 key questions. First, will this thing actually work? Second, is it safe? Third, can we afford to make it? And finally, and this one's a biggie, can we actually build it with the stuff we have? Answering these questions is what turns a pretty good idea into a rock-solid plan. Okay, so once you've picked your champion idea, it's time to draw the map. And in the world of engineering, we call that map a blueprint. And let me be clear, a blueprint is way more than just a quick sketch. Think of it as the complete step-by-step instruction manual. Here's the real test. Your blueprint should be so clear, so detailed, that someone who has never met you could pick it up and build your invention exactly the way you imagined it. That kind of precision is why teams can build massive, complex things together without making a mess of it. And you can see the difference right here. Over on the left, that's a simple sketch. It gives you the vibe, the general idea. But look at the right. That is a blueprint. You've got exact measurements, labels on every single part, little notes on how they all connect, and it even says what materials to use. See? The details are everything. Now, that last thing I mentioned, materials, that's so important it honestly needs its own section. Seriously, choosing the right stuff to build with is one of the most important things an engineer does. So let's do a quick run-through of the 4 big properties engineers are always thinking about. First up is strength. Basically, how much punishment can a material take before it just gives up? We're talking about its power to resist bending, cracking, or flat-out breaking. I mean, think about it. You wouldn't build a bridge out of cardboard, right? Of course not. It has super low strength. You'd use something like steel, which is incredibly strong and can handle a massive amount of force. Okay, next up, we've got flexibility. It's pretty straightforward. Can a material bend and stretch without snapping in two? That's flexibility. And the contrast here is huge. Take a piece of wood. It has pretty low flexibility. If you try to bend it too far, it just splinters. But then you've got rubber, which is the total opposite. You can bend it, twist it, and it just pops right back into shape. Then you've got water resistance. You can think of this as a material's superpower against water. Does it keep water out and stay strong, or does it turn into a soggy mess and fall apart? This one's super easy to picture. A paper bag caught in a rainstorm? Yeah, it's a goner. That's really low water resistance. But a plastic container? It can hold water for years and be totally fine because it has high water resistance. And last but not least, we have weight. It's exactly what it sounds like. How heavy or light is the material? And this can be a total game changer. If you're building an airplane, you need something strong but also super lightweight. But if you're building an anchor for a ship, well, you want the exact opposite. You want something really heavy. Okay, so let's tie all this together. Let's see how a real engineer uses these ideas to solve a problem that I bet we're all familiar with. So, I want you to imagine you're the engineer. Your job is to design a brand new playground slide. It has to be strong, it has to be safe, and it needs to survive outside for a long time. What material are you going to pick? Well, you might think of wood at first, but splinters are a problem, right? And it can rot if it gets wet. Okay, what about metal? Well, metal is definitely strong, but it gets crazy hot in the sun, and it'll start to rust. So both of those pretty common materials have some big safety and durability issues. And that's why the engineer's solution is a specialized kind of plastic. Why? Because it checks every single box. It's strong enough, it's super smooth, it doesn't turn into a frying pan in the summer, and it's totally water resistant. It is the perfect material for the job, all because the engineer carefully thought about its properties. And now it's your turn. Time to take everything we've just talked about, from picking the best idea to choosing the right materials, and put it all into practice on your own project. So as you get started, this is the mindset I want you to have. You're not just trying to make something that looks cool. You're thinking like a real engineer, making smart, practical choices that are going to lead to a design that actually works. So here's your mission. Step 1, look at your ideas and choose the single best one using those 4 key criteria. Step 2, create a detailed blueprint for it. I'm talking measurements, labels, the whole shebang. And step 3, make a list of your materials and explain exactly why you chose them based on their properties. And as you do that, ask yourself this: what's going to make this plan more than just an idea? What makes it a true engineered solution?